The first term I need to introduce to you is called as vertex. Vertex. Vertices, vertex the plural. This purple dot, vertex, okay? So, I already tell you, right? If this is the vertex, then this graph got how many vertices?
5个 5
5, okay? Then you tell me, what is the vertices,
A B C D E.
We have the second term, called as edges. Edge, okay? Plural is edges. What do edges mean?
The line.
How many edges do we got? Same graph,
6.
we have 6 edges. If you want to do graph, you need to record down your vertex and your edges, correct or not? There are two type of graph, directed graph and non-directed graph. Okay, this one is called direction. Because sometimes in a road, right, you can travel from B to A. Doesn't necessarily mean you can travel A to back to B. For your worksheet practice, right, your worksheet practice is using all undirected. Meaning, right, A can travel to B, B can travel to A also. Okay, they can be also multi-graph. Example, you got A, right? You got B, you got vertex A, you got vertex B. And then you got 2 edges, you got 2 edges. And this can be called as a multi-graph. Then the third term, we need to learn the third term. The third term is called as adjacent. What is adjacent of C?
D and B.
Can you see these edges? If C is connected to D and C is connected to B then the adjacent is D and B. Let's see directed graph. If I say adjacent of A, let's see adjacent of A. The answer is E. Okay. Your adjacent list, you need to print something like this. Okay. If you cannot list out all this type of thing, how do you do coding? Correct or not? You don't know what it's doing. How do you do coding? This is why it's important. E.
EBA.
Okay. So then what is the adjacent of A? E only, Okay. B.
A and C.
A and C. Okay. C.
D.
D. Okay. D.
None.
Okay. D don't have E.
D, B, D and B.
D and B. Okay. Then our adjacent is completed. This one completed. Okay. Then we want to do it in adjacent matrix. Okay, again, link.
Link E.
Link E, correct. 这样子来写So like this, how do we convert this? The same thing, okay. This one is AC, B got A, C, and then C got D. This is your adjacent matrix. Don't follow my UML. I don't know my UML correct or not one. Okay. Still remember, in your DSA link list, right? You got your DSA list node, okay? You got your DSA list node inside here. And then, right, you have other private class. What is this private class? This private class is the iterator, okay? Iterator inside your DSA link list. Your DSA list node, right, got a next, got a previous, okay? And then how do you code your graph? Your lecture slide is using node, okay? List node. Do you know what is the list node meaning? The node is this one, this one.
Next previous.
So do you want to use list node to do? For me,
which one easier?
Linked list is easier. Because if you want to use your list node to, you need to set next. This one is single link, okay? Single link. Last. If you are so raging, you go and use okay? No problem. Go and use back your DSA list node. Can you imagine out how to use linked list? Don't look at this first, don't look at this first. This one we would insert later, so we look at this part first. Insert last, okay? We are using insert last. We can use our linked list. So example, this one is A, this one B, this one was C, okay? This part can get it. After you insert A, right, we want to link it, we want to link it together. Okay? Because A got adjacent, A got adjacent, B and E. And then B got adjacent of what?
C and A and E.
We got C and A and E. Before this, we confirm need another class, correct or not? We need a class. We need a class. Inside our DSA graph, DSA graph is the main thing. It's the main thing. Then this main thing, of course, this vertices list is a type of linked list. Okay? But of course, you want to use list node can also. I didn't say you cannot. Okay? So the first thing, this one is a linked list, okay? Linked list. Okay, this one is a linked list. You got vertices A, you got vertices B. And then this A, right? A is a class, A is a class. You are storing a graph vertex class, okay? Orange color. This is a graph vertex class. So our list, we will store a class, individual class, A, B, okay? So imagine this as orange class. Then inside this orange class, we need to store the adjacent as well. Correct or not? Inside the A, we need to store the adjacent. Inside the A, we need to store the B and E, okay? We want to record the adjacent. Example, inside this A, right? Inside this A, I want to record equal adjacent of B and E. Linked list, okay? Use linked list. Inside here got a linked list again.
InsertLast.
Yeah, insertLast, okay? We are using insertLast. In our DSA list node A, first we insertLast what?
InsertLast B.
InsertLast B, then we insertLast E, okay? So we insertLast our B, we insertLast our B, then we insertLast our E, okay? We insertLast our B, we insertLast our E. In our B, our B adjacent got what?
AEC.
Okay, so we insertLast, just follow alphabetical order, A, C, E, okay? Like this, So can you imagine out already how to print this thing? Go into each linked list, and then in each linked list, right, you get the adjacent list, and then you get the adjacent list, then you get each of the linked list and print out the value. Because your linked list got set the value, correct or not?
Why B point back A like that?
B, label
Point
B, point got adjacent A. Meaning, right, this B got 1A.
Okay.
Then why C is like that?
C 其实有 A 还有 B 的，它有一个 B 的，还没有 insert 进去。所以这个 B 等下你 B 其实是这样子 point 的啦。Let's look at your graph vertex. Your graph vertex, right, would have a label string, okay? We are looking at the orange part now, okay? The orange, orange class, okay? The orange class is represented by this one. Entire thing is the orange class. Inside the orange class, got adjacent list. The adjacent link list is this one, okay? Can imagine our. So our DSA graph vertex, initially, right, we got the label, label. Can you imagine out what do we do with the label? Label used to store what?
Store ABC.
Correct. We are storing this blue color, okay? Storing the blue color text, ABC. I tell you first, I give you the background idea first. Your graph would give you a sample like this one, A, B, A, C, B, C. Okay, later in your practical worksheet. It will give you A, B, A, C, B, C, okay? So when it give you A, B, A, C, B, C, right, then you need to insert it, insert like this. Insert into this, okay? A, B, A, C, B, C, when you draw into a graph like this, when I give you an adjacent link list, you confirm can draw a graph already, correct or not? So example, and then I give you CD, and then CD.
Square?
Correct. Answer is square. See, if I give you the adjacent only, A, B, C, D, you can draw it out again, okay? You can draw it out again. This is what it means, okay? A, B mean A connect to B, and then B, C mean, B connect to C, Continue, okay? Continue the cycle, okay? So the same, when your worksheet, right, provide you A, B, then you want to start a DSA, this thing, vertex. Open a vertex. You need to open a vertex, okay? Inside your graph, right, you got a add edge, okay? You got a add edge. Your add edge would take in one vertex name. Example, we insert A, and then we insert B, okay? Then your add edge, what is the next step?
The AB is vertices, is it?
Yes, inside your DSA graph, right, you got a vertices list. Then you tell me, where should I put it? So example, vertices list. Vertices list, we call this as VL, okay? VL. Your DSA graph got a linked list. And then your vertices list will use to store this we used to store this we used to store your DSAGraph vertex. We used to store your DSAGraph vertex like this. Can imagine
A, B, C, D.
So initially, right, first thing you need to check if this name already existed in the linked list, correct or not. So the first step is you have a getVertex method. You have a getVertex method. Can you imagine what is the purpose of getVertex? You want to find the vertex, is it existed already? We find A and B, we find from this VL, we find from this VL. Is it existed already or not? If it's not existed, then only we presume. So let's say we got a DSAGV, DSAGV. Oh, DSAGV is this one okay. Let me label it better. DSAGV, DSAGV, okay. Our DSAGV V1 is equal to get vertex, okay. We get the vertex. The vertex is tagged in what? Tagged in what?
Taking the string of what he wants to search.
Yes, correct. Initially, you initialize vertex 1 and vertex 2. Okay, so get vertex. So when you get vertex initially, it's empty, then what is V1? V1 is null. Okay, now V1 is null. If V1 is null, we want to add vertex. So we add vertex what?
A.
Like this add vertex A Okay, if V1 this one is V1, then you check the same for V2 correct or not? If V2 is empty not in the list then only we add B okay? So after this okay, our linked list got A and got B already. After we add vertex your linked list will look like this. You got an A, and then you got a B, okay? Got an A, got a B already, okay? Get vertex. Where is get vertex? Or get adjacent. Your lecture slide is called as get adjacent. Get adjacent.
So get vertex is get adjacent.
Which one make more sense? Get adjacent or get vertex? Depend okay? If you prefer get adjacent then you use get adjacent okay? Then after we add the vertex after we add A inside this vertices list after we add it inside we add this inside and what else we need to do we need to add the adjacent now this one is get adjacent this one is add adjacent if you are not confusing it's okay okay? Make sure you know what you are doing meaning now we want to add adjacent inside here we want to add adjacent inside the B but this one in your slide is using get adjacent this get adjacent means we are getting the orange one. We are not getting the green one Adjacent linked list is the green one. Okay, green one. This adjacent linked list right would have another linked list like this.
所以是要有两个
两个 linked list，一个是在外面的，一个是在外面的，这是另外一个 private class 的，这个 private class 在里面。
所以这个青色的是放 A 的 adjacent 是什么什么 ，B 的 adjacent 是什么什么，然后这个 vertices list 是放 like how many vertices 总共有几个 vertices？
Correct. Our vertex is orange color, and then our adjacent is green color. Okay, this one is just an edge like this. Like this. Okay.
Okay.
When we insert our A is inside here. Insert B is inside here. But A got adjacent of E and B then our E and B is stored inside here
inside here.
Inside here. 这个 get adjacent 是 get 这里的全部 adjacent， get 这里的你的 linked list 已经有了什么 adjacent。
OK， 明白。
所以自己好好来你要用 get adjacent 就不要 confuse我是用 get vertex What is the next step? We want to insert this green one Then our V1 right? Our V1, which method do we call? Our V1? V1 is a DSAGV. V1 is a DSAGV. So it's from here.
So add adjacent.
Ah, correct. The answer is add adjacent, huh? Add adjacent of, we add B, okay, we add B. Add adjacent B, okay? So we want add adjacent B, then this one, right, would have something like this, B first, okay? Imagine this is for A. This one is for A1. Then this one adjacent will have B, okay? So make sure you are not confused. If you say get adjacent, get adjacent is not get this adjacent. Get adjacent means get this adjacent. So I use get vertex, okay? Your A, after you add B, right, then this here got B, okay? This B is the same B, remember, Java is reference, Java is reference. You are not copying, you are not making a new B, you are just referring it, okay? Refer it. This one is A, this one is A, and this one is B. This one is B, okay? So this is a V2, our V2, right, will add a A, okay? We will add a A. We will add a A, okay? So it will look like this. Make sense? Now we add A here, okay? So V1, we get vertex A. After we get vertex A, what did we check?
Check if the vertices list got A or not.
Yes, we check if the vertices list got not. Got
So got.
Got V1 is not null then we skip this We skip this then we follow the V2. V2 get vertex E. Got
No, don't have. So add E.
So we add E okay. So now we add E okay. Add E. This one is E V1 is at A, okay. V1 is not null. After you add adjacent, this one add what? Add E, okay. V1 you want to add E. So you add E, your E will be added in here, okay. Make sense,
Yes. Add A into E.
We add A into E, then we add into here. Then E will get adjacent of A, E will get adjacent of A.
Okay.
Proceed like this, okay. And then our display as list, this one you need to implement yourself, If you display as list, right, you're displaying like this. At HAB, right, the B doesn't get created again, the B is referred to here. When you create the vertex A, right, then in the adjacent of A, then you are going to refer the B inside. So you are going to insert last B, okay? Then you insert last the B. And then after you insert last the B, right, then you'll do the same to the vertex B. In vertex B, right, the adjacent list you're going to insert last the A. Just refer, okay? Just refer. When we add H, A, and E, right, A already existed in the vertex list, okay? If A already existed in the vertex list, we don't do anything. And then E just now is not in the list, then we created an E, okay? We created an E. And then at the A, right, in the vertex A, we are going to add adjacent, meaning we insert last. We insert last, we are going to insert the E, okay? And then in the E, right, in the vertex E, we are going to add adjacent at the adjacent of A, okay? If we add H, B, and E, right, then our V1, example this is V1, right? Is V1 already existed in the vertices list? If it is in the vertices list, right, then we don't create a new vertex. Then we just searching. We loop, and then we get the position of B, right? And then we are going to add the adjacent, okay? What is the adjacent? The adjacent is the E. Before this, right, we need to also get the vertex of E. So we check first. Did our vertex has already an E? Then we loop each one, 1, 2, 3, and we found the vertex, okay? We found the vertex, right? Then we are going to put this refer to the adjacent, okay? So we are going to add the E inside here, okay? Add the E. And when we are at E, right? E, we are going to add B also, okay? The most important thing is depth first search and breadth first search. Oh yeah, this one if you can look at your lecture, direct understand it, I salute you. This one is the most difficult part. You see it in your binary search tree. Your binary search tree already have a depth first search. And then you got a breadth first search also. What is the difference between depth first search and breadth first search? You will see this a lot. It is very useful one. DFS and BFS. You will see this term a lot in DSA. What is the purpose of DFS and BFS? The answer is to transverse. You need to explore all the path. You need to explore all the path. So let's look at depth first search. The idea of depth first search is so long there's a node, right? We are going to traverse the adjacent, okay? So example, right? Say we start from A. If we start from A, right? Then we are going to move forward, okay? Move to this one. And then, right, we are going to put it to our stack, okay? We put it to our stack. And then the B, right, we find the adjacent again. We find the, and when you output, right, you are going to output like this. You start from an A, right? Then you print AB, okay? You print AB. I'm going to show you another way of doing it. If you don't want to put A to the stack, right, what you can do is store the A as argument, okay? So later you can print the argument with the remaining non-visited vertex. So when you're at B, right, then you're going to get the adjacent again. You get the adjacent, right? C is not yet visited. If C is not yet visited, you add it to the stack, right? Then you're going to print BC, okay? You're going to print BC. And then, right, your C, right, got what adjacent? Your C got D adjacent, right? Then you add D to the stack, right? Then you're going to print CD, okay? And then, right, your D got what adjacent? D got adjacent of C and A. Both are already visited. Then, right, you're going to go backward, okay? Go backward one time. And then you're going to pop it. You pop the D, okay? You pop the D. And then you're going to C, right? C got what adjacent again? C got another E adjacent, not yet visited, right? Then you're going to push it to the stack, right? Then you are going to print CE like this, okay? So I'm going to show you another method. If you don't want to put everything to a stack, right? And take in 2 items from the stack, right? What you can do is you do like this. You put the temp to the argument. So example, right, we start from A. So we put our argument as temp, for example. So we start as A, right? Our argument is A. And then in A, right, we get the adjacent, get the adjacent. What is the adjacent? B. B not yet visited, right? If B not yet visited, we'll put it to the stack, okay? Put the B to the stack. And then, right, you're going to output AB, okay? Output AB. Each time when you put to the stack, you're going to print the temp and non-visited vertex. So in the B, right, you're going to go to the vertex of B and get the adjacent. The adjacent is A is visited, right? And then you go to the adjacent of E, okay? So right now, you are at B, right? Your temp is B, your temp is B. And then when you are at E, right, then your temp would become E, okay? So you're going to add E to the stack, and then, right, you're going to print B and E, okay? So you go to E, you're at E now, E, right, is A visited, A is visited, and B is visited already. So you don't need to do anything, okay? Don't need to do anything. So when you are not doing anything, right, this one you can ignore it already. Now we are going to go back at B. After we finish loop the adjacent, right, then you're going to pop the stack one time, okay? You're going to pop the stack one time, okay? Remove the E. And then at A, right, just now you're starting from B. It's already visited also. So you pop the stack one time again, okay? Then the remaining E adjacent at vertex A already visited, right? So we don't need to do anything. Let's look at breadth first search algorithm. Breadth first search algorithm, right? We are going to visit the neighboring adjacent, okay? Example, we start from an A, right? We start from an A. then you put A to the queue. Okay, this one is your lecture slide. For me, right, I will put the A as an argument. We left with A got what adjacent? A got adjacent of B, right? And then we are going to put B into the queue. Okay, we put the B into the queue, and then A got what adjacent? We got D and we got E. Okay, then we put D and E into the queue. And then, right, when you put it to the queue, right, you are going to print it. Okay, you're going to print it. Just now you print A and B already. Okay, A and B already. And then you're going to print A and D. Okay, you're going to print A and E. After this is completed, right, you're going to move out the first one you insert. You move out the first one you insert, right, then you are going to explore the adjacent of B. Adjacent of B is A already visited, E is already visited also, and then you go to C. Okay, C is not yet visited, we add it to Q, and then we print it, so we get BC. Okay, get BC. So later, right, after you finish this part, right, you remove one time from the queue again. When you remove one time from the queue, right, we are at D. At D, right, A is visited, E is visited, and C is visited. And then, right, we do nothing. And then, right, we remove E again. We remove E again. E got adjacent of A, E got adjacent of B, E got adjacent of C, all is visited also. Okay, we DQ again. And then at C, right, at C, we get the adjacent of C, which is B, E, D, all is visited again. So in the end, right, you have this type of list. I'm going to show you my method. My method, right, I'm going to, and for your information, right, I'm not using a real stack class. I'm just going to use insertLast. It's going to perform the same. Okay? You don't need to import your queue. You don't need to use your DSA queue. A DSA linked list will be enough. Meaning you insert last, you're going to remove first. Okay? If you are simulating, okay, simulating. So right now, right, let's clean our template. We are going to do a breadth first search. Our breadth first search, right, is going to visit the neighbor. Okay, visit the adjacent neighbor, and we are going to use a queue. Okay, so we also have a temp. I put my temp as my argument. Okay, so example, right, we start from A also, meaning, right, we are going to pick first our vertices list. When we pick first, right, our temp is A. Okay, our temp is A. And then, right, in A, right, we get the adjacent, we get the adjacent. The adjacent is B. Okay, the adjacent is B. So we put it to our queue. Our queue is B. Okay, put our B, and then we are going to print the argument plus the not visited vertex. Not visited. We print the word not visited one. Okay, and then, right, when you go to AB, right, you're going to get the next adjacent. You get the next adjacent of the A, which is E. Okay, E is also not yet visited, right? Then we'll put it to the, okay, because we're going to insert last. Okay, insert last. Okay, so we're going to print AE also. We print AE. Okay, after you finish this step, right, then you are going to remove first. Okay, when you remove first, right, you're going to B. You're going to B. Okay, when you're going to B, right, then your temp is B now. Okay, no longer A, your temp is B. When you're at B, right, then you check, is A visited? A is already visited, right? Then you check E, is E visited? E is already visited also. Okay, and then when it's done, right, we are going to remove first. Okay, we remove first from the stack. Okay, this one is E. This temp, right, no longer is B. This temp is E now. When this is E, right, we go to get the adjacent. A is A visited, A is visited, right? Is B visited? B is also visited, right? Then we are done. And then you want to write a method called reset all visited. This one is I added myself. It's not in this. Reset all visited, right? Set the visitor, set it to false. Because after you DFS, right, you need to reset it. You need to reset every node. If not, or if you didn't reset, when you do a BFS, then everything will be wrong. Can you imagine? Because when you reset the node, right, you want to say as visited. The second time you do a BFS, you need to reset it first before you search. Okay? For me, I do my DFS inside the graph vertex because your adjacent linked list is private. So if you don't want to process the BFS inside, then you return here. You get the adjacent linked list. So inside here, you can get the linked list. Adjacent, you can get the adjacent.
So it's just to pass out the linked list.
If you don't want to do like this, for me I do it inside.